Hi all the students of Narayana 9th standard. Today here I am in front of you all to discuss the topic work power energy, assignment number 17. Now in this assignment, let us go with the first question. The first question which is coming for you all over here is, when a spring is compressed by 3 centimeters, the potential energy stored in it is U. Potential energy stored in it is U. When it is compressed further by 3 centimeters, that means further 3 centimeters. First it is compressed for 3 centimeters and further it is compressed for another 3 centimeters. Then the potential energy is. So let us take in the case 1. Case 1 as potential energy U1 is equals to work done. Potential energy is nothing but equal to the work done. Work done by the spring is half K x square. Now U1 is going to be equal to half. Did they give any K value? No. Okay, let us take K. And what is this x? X is given as 3 centimeters in the case 1, so I will take it as 3 square. Now next, let us go for case 2. Case 2 is nothing but further it is being moved to 3 more centimeters. Further it is compressed for 3 more centimeters. First it is compressed only for 3 centimeters, again it is further compressed for another 3 more centimeters. Now what happens over here is U2 is going to be equal to half K x square. Now here x square, this is x1 square and this is x2 square. Now half K, what is your x2? x2 is 3 plus 3, which is, I can write it like this. So you have a compression over here. I am going to write it like x2 square minus x1 square. Now that is going to be equal to 3 plus 3 is 6 square minus x1 square is nothing but 3 square. So 3 square. So you will be left over with U2 is going to be equal to half K. Here 6 square is 36 minus 9. Now you are going to be getting your U2 value as U2 is going to be equal to half K. 36 minus 9 is 27. Now that is your U2 value and this is your U1 value. Now the potential energy is, that means what, with comparison of the potential energy 1, you want to find the potential energy 2. How much of increase or decrease it has happened because of compressing another more 3 meters. Now let us check 3 more centimeters you have compressed. Now you can do ratio of that, which is like U2 by U1. Let us take this one as equation 1 and this is equation 2. Equation 2 by 1 is going to give you like half K into 27 by half K into 3. 9 into 9. So half K gets cancelled. 1's a 3's a. So your value U2 is going to be equal to U1, 3 into U1. So this is your answer. So your potential energy is going to get increased for 3 times more when you further compress it for 3 more centimeters. When it is already at 3 centimeters, if you compress it more than 3 centimeters to another 3 centimeters, your potential is energy is also going to get increased for 3 times. So this is your answer, which is 4th option. Let us go for next question. Hope this is helpful, and let us go for the second question. In this second question, you can observe a 4 kg mass is given. M is equals to 4 kg. M is equals to 4 kg. Moving with a speed is given, which is 2 meter per second. collides with a spring bumper negligible mass and having force constant, which is K, is equals to, K is also given, force constant K is given as 100 Newton by meter, and the maximum compression he wants of the spring bumper. If you want the maximum compression over here, then you need to find the compression value, which is X. Now here they have given you some velocity. Let us equate the energy is equals to work done. Energy is equals to work done. Now how much of energy is going to be spent over here? We will talk it in terms of velocities. So we will talk it like kinetic energy. Kinetic energy formula is half mv square is going to be equal to the work done due to the spring. Work done due to the spring is half k x square. Okay. Now what you will have, half gets cancelled, you will have mv square is equals to kx square. Now here you substitute that values, which is m is nothing but 4, v is nothing but, so 2 square is equals to, k is also given, which is 100 newtons, so k is 100 newton, a newton by meter, so 100 I am going to write it into x square. I want x value from here. Now 4 into, this is not u sir, this is 4, don't get confused. So 16 is equals to 100 x square, which is nothing but x square is going to be equal to 16 by 100. From now x is equals to root over 16 by 100, which is nothing but 4 by 10. So x is equals to 4 by 10. So your value is 0.4 meters. Your value is 0.4 meters, when that is going to give you option number 2. So your answer is option number 2, which is 0.4 meters. X, that means because of that energy and that much of work done, you will have a compression of 0.4 meters of displacement in the spring. Let us go for the next question. Hope this is helpful for you. This is your third question. In your third question, you can observe that they gave you a massless spring. That means the spring is not having mass and you don't concentrate on the mass of the spring, and K is given as 40 Newton by meter, hangs vertically to a ceiling, and they gave you mass also, and that is held freely, okay, free end of the spring, and held in the such a position that the spring has its natural length and suddenly releases. The maximum change in the length is, so they ask you to take gravity as 10 meter per second. Here they are asking you maximum change in the length. So when you want to find the change in length, then again the same formula will apply. Energy is equals to work done. Energy in this case is potential energy, mg. Potential energy formula is mg x displacement is equals to half k x square. Now from here, if you want to cancel, x square and x gets cancelled. You will be left over with mg is equals to half kx. What you want from here? Change in length. Change in length is nothing but I need this x value. Now here, how do I find that x value over here? I will try to substitute the values which are given. Mass is given as 0.2 kg, 0.2 into gravity is said to be taken as 10. So this is, I am taking it as 10, is equals to half. K value they ask you to take somewhat around 40. So 40, I am going to take it as 40 into x. 2 1s are 2 20s. So from here, 10 into 0.2 is 2 is equals to 20x. So from here, x is equals to 2 by 20, 1 by 10. So x value is equals to 0.1 meters. So in this, the option is third one. They have given you a printing mistake over here. Please check it out. Your option is 0.1 meter. So x value is 0.1 meter. That means there is a change in length. The change in length is 0.1 meters. So your option is 3. Hope this is helpful for you. Let us go for the next question. Right. In this question, you have two like charges of magnitude 10 power minus 9 coulombs each. That means there are two charges. Let us take Q1 and Q2, and each is having a charge of 10 power minus 9 coulombs. Each are separated by a distance of 2 meters in a free space. You don't have some permittivity over there. If the distance between don't have permittivity means you have free space permittivity. If the distance between charges is increased to 4 meters, then the ratio of electrical potential energy formula is 1 by 4 pi epsilon naught Q1 Q2 by R. Now let us talk about that. I want the ratios of that because it has changed for a distance. It has been separated. Let us take this is Q1 and this is Q2. They both are separated with 2 meter distance, and after that the distance has been increased to 4 meters. Now let us take it as potential energy 1. Potential energy 1, U1 is nothing but equal to 1 by 4 pi epsilon naught into Q1 Q2 by R, and this R is nothing but, first R is 2m, so I am going to write it as R1, and U2 is nothing but, U2 is equals to 1 by 4 pi epsilon naught Q1 Q2 by R2. Now anyway Q1 and Q2 are same and its magnitude is 10 power minus 9 coulombs only. So I am not writing it because you don't go with that calculations and all. Now here, if you try to find out the ratio of this particular thing, what will happen is, you can cancel this one and this one, permittivity, and this one, this proportionality constant, like 1 by 4 pi epsilon naught and 1 by 4 pi epsilon naught is going to get cancelled. Q1 by Q2 is same, and here also Q1 by Q2 is same. There is no change in the charge, that is 10 power minus 9 coulombs only. I am directly cancelling it right here itself. Now what you will be left over with? You will be left over with U1 by U2 is going to be equal to U1. It is going to be equal to 1 by R1 by 1 by R2. Now what is your R1 value? R1 value is 2 meters. What is your R2 value? R2 value is 4 meters. Now if you try to solve that, you are going to get U1, that is potential energy, if the first first distance is 2, is equals to R2 by R1. Now if you substitute the values, you are going to get it like this. U1 by U2 is going to be equal to, R2 value is how much? 4 meters. R1 value is how much? 2 meters. So the ratio is U1 is to U2 is going to be equal to 2 is to 1. So your answer over here is second option, which is 2 is to 1. Right, second option is your answer. Now let us go for next question. Hope this is helpful for you. Let us go for the next question. In this question, you will be discussing about the charges minus Q, capital Q, and again minus Q are placed along x-axis. Now let me draw one x-axis. This is x-axis, and this is the 0 point, x at 0 value, x at a value, and x at 2a. Let us take at x0, you have minus Q. At xa, you have capital Q. Let us think on x-axis the distance from here to here is a, and here you have capital Q, and another one is here which is minus Q. They gave you three charges over here, three charges. One is placed at 0 point, another one is placed at a point. From 0 to here the distance is a, and again from there to here you have another a. Okay, from here to here this is a. Now there you have another charge which is minus Q. Now you have three charges with some differences. From starting to the ending you have a distance like 2a. Okay, forget about this. You have 2a complete. From here the starting point to there you have 2a. Now if I want to find out the potential energy over here, potential energy over here, potential energy over here, that potential energy between these two charges, potential energy between these two charges, and potential energy between this one and that one. Now I want to write down like total potential energy U, total potential energy U is equals to potential difference between this charge and that charge is nothing but you will have it as U1 plus U2 plus U3. Okay, potential difference between these two, potential difference between these two, and potential between these three, these two, this one and that one. Last you will be checking it out. Now U1 is between these two, U2 is between these two, U3 is between this one and that one. Last one, first one and last one. Now if I want to substitute that values, I am going to get 1 by 4 pi epsilon naught, 4 pi epsilon naught as common in all those three. So I am going to take that thing as common first itself. Right now itself potential energy formula is 1 by 4 pi epsilon naught Q1 Q2 by R square. Now from that I am taking 1 by 4 pi epsilon naught as common, and if the potential energy of the system is 0 they told, that means this completely it is equal to 0. Completely set is equal to 0. At last you will be understanding that. Now from here U1 value is nothing but minus Q, and Q2 is capital Q by A, because radius, the distance is A over here. Next let me take another one. I'll draw this to little side because it will be helpful for you. So first it is at x position A, and here it is a position like 0 to A, and here it is completely the distance is 2A. Okay, from here to here it is A. Now here you have minus Q, here you have capital Q, here you have minus Q again at the last, which is called as 2A over here. Okay, now next one. Next, between these two, if I want to find out the charges, so potential energy or potential difference between these two charges, then I am going to apply it like minus Q capital Q by A, because the distance from here to here is also A, the distance from here to here is also A. So that if it is 2A from here to here, it will be half of it is nothing but A. So let me take that. And next what else you will be having? This one and that one I will be checking. So from there I will be getting minus Q into minus Q plus Q, that is nothing but Q square by the distance over here is 2A, so I am going to take it as 2A. This is 2A. Now what I am going to do is I am going to equate this with 0, because they told you if the potential energy of the system is 0. Now if you want to solve little more from here, this is you can take minus Q common from this. Minus Q by A could be taken as common from this. Then what you will be having 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught into minus Q by A. You have taken that as common. Now if you take this as common from this whole equation, you will be having capital Q left over, capital Q plus another capital Q plus another capital Q, and minus q by 2 you will be left over with, right? And now that is equals to 0. You send this multiple factor that side, what you are going to get then? If you send that multiple factor that side, you are going to get q plus q, 2q you can write it as 2 capital Q minus q by 2 is equals to 0. Now what will be left over here? You just send this thing that side. So you want the ratio of these things, no? The q, capital Q and q is your question. You want to find the ratios of these two. So we'll do one thing from here. So if you want to find the ratios, you can write it like this: 2q is equals to capital Q by 2, capital Q by 2, and here you are going to get, if you send the 2 that side, you are going to get 4q is equals to capital Q. Now from here, if you try to find the ratios, how much you are going to get? 4:1, right? So if you try to find it out, you can do it like q, capital Q by q, you send that 4 that side, is equals to 1 by 4. Sorry, your ratio is going to be 1:4, not 4:1, right? Your option is 3, 1:4, not 4:1, sorry. So from here I hope you all understood these equations and questions. So I think this is helpful for you. Let us meet in the next assignment. Until then, bye.